Mutual induction. So as shown in this figure, we have two coils P and S. The coil P is connected in series with a cell through a tapping key. And this coil S, it is connected to a galvanometer. Alright. So now, when this tapping key in this coil P, it is on, so the cell will produce a current I in the coil P. Now this current I, which is flowing in the coil P, will produce a magnetic field in this coil P. So initially, right, when the key is on, what happens to the current in the coil P? The current in the coil P, like before, it starts increasing for some times before it becomes maximum. So during that period, when the current is increasing, then the magnetic field which is linking with the coil P will change. And hence, the magnetic flux linking with the coil P also change. Alright, so what we found here is that in this second coil S, we did not connect any battery, but just a galvanometer. So because of the changing magnetic flux that is linking with this coil P, you will find a current, right, is indicated by the galvanometer in the second coil. Okay, so this means that the magnetic flux which is changing with the coil P, it is also linked with the second coil S, and that is why we get a current in the galvanometer. Okay, so this phenomenon of production of EMF in the second coil due to a changing current in the first coil is known as mutual induction. So please note down here that these two coils P and S, they are known as primary coil and secondary coil, and the two coils are placed close to each other. Alright, okay. Now, what is the the magnetic flux which is linking, right, in the two coils in this case? Suppose at any instance of time, let's say the magnetic flux is phi, and this magnetic flux, it is linking in both the first coil and the second coil. Now this magnetic flux, like in the case of self-induction, it is directly proportional to the current I which is passing in the first coil. Or we can say phi here is equals to some constant, and that constant is m. Okay, so this m is a constant of proportionality, and it is known as coefficient of self-induction, or we can say it is known as, sorry, not coefficient of self, but mutual induction, or we can say it is mutual inductance. Okay, all right, so this is my equation number 1. So if this is the magnetic flux which is linking with the coil, then what is the EMF? What is the EMF that is induced in the two coils? So the EMF induced in this case, if you remember, it is equals to minus d phi upon dt. Or you can say E is equals to minus, instead of phi you will write mi. Now m is constant, so we take it out and we differentiate only current. So this is my equation 2. Okay. Now from these two equations, alright, we will define about mutual inductance. So in equation 1, if the current is equals to 1 unit, let's say 1 ampere, then phi is equals to m. So which means the mutual inductance of two coils here is numerically equals to the magnetic flux linking with the coil when the current of 1 ampere is passing through the primary coil. Okay. Similarly, from equation 2, if I substitute di upon dt as 1 ampere per second, then what will happen to E? E is equals to m. forget about minus sign. Okay, take only magnitude is equals to M. So it means the mutual inductance is numerically equals to the EMF induced in the two coil when the current in the first coil is changing at the rate of 1 ampere per second. Okay. Now, coming to the SI unit of mutual inductance. From here, okay, from equation 1, this M is equals to how much? Okay, M is equals to phi upon I. So we know phi is magnetic flux and it has a unit Weber. I is current, so the unit is ampere. So Weber per ampere is the SI unit, or we can say this is equivalent to Henry. Similarly, from equation 2, when you find out M, you will get M is equals to E upon di upon dt. So the SI unit of M here, it would mean volt per ampere second. So again, this is equals to Henry. So please note down, the SI unit of both self-inductance and mutual inductance is the same, that is always equals to Henry. Okay, so next is we will look at the how to find the mutual inductance of two long solenoid.